10 nanometer. There is no any alternate. See, for homoannular, should I add 39 or not here? Why I have to add? Because 39 means this homoannular in the ring there are two double bonds. That's why we are going to add 39. Okay. Now for extended conjugation, how much should I add? Here there is no any double bond which is attached or which is in conjugation with these two. That's why for this particular structure I have to add 0 nanometer, right? 0 nanometers are here. For exocyclic bond, again for this ring system there is no any double bond which is from outside through single carbon. That's why for exocyclic again I have to add here 0 nanometer, right? Substituent, now substituent, see, we can highlight this bond or this atom carbon, then second, third and fourth. Why I am highlighting? Because it is a part of a Diene system. So this atom has one, this is not having any substituent, this is also not having substituent, this is also having one substituent, so total two substituents. So I will have to add here 10 nanometers since I have two exocycle substituents. So then I have to make it total. Again there is very silly mistake is done that you can use, if it is allowed, you can use the calculator here, okay, or otherwise do the careful addition of this. Many a times you are finding everything clear, but to the you are making a mistake in addition. It's a simple, but still if it is not matching to the final value then it will be of no use. Okay, this is first example. Is it clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now the second example, see on the screen there will be only one example now. Similar type of example is there, only the difference is that here we have two substituents, more two substituents. See, base value 215, then homoannular is 39. There is no any extra or extended conjugation, so we will add 0 nanometer for that. Exocyclic, again there is no any double bond which is present through outside, so we add 0 nanometer. But now see the substituent. This bond is having one, this carbon is having one substituent. When you go here, this is CS3, right? Methyl group. So this is a substituent. This is not a hydrogen. That's why this is a substituent. Okay. This is a second. This will be like a third and fourth. So total there are four substituent now. So you have to add how much?
20.
20 nanometer. Okay, so this is the second example. I'll just make it save and I'll delete it. Okay. I think so far so many problems that you will able to solve. Now next thing here, see the next example. Now there are two rings. Okay, for finding the lambda max for such a example, what we will do, we will again write all the five things. I'll just again zoom it. It will be like more and more visible or clear to you. See, base value, no doubt you have to write 215 nanometer. Homoannular, how many rings are there? Two rings. You have to find two bonds in one ring. So how many rings are like that? There is only one ring. Okay, so you have to add for homoannular 39. Extended conjugation. See, for this, for finding the extended conjugation, you should highlight which Diene system you are going to consider. Here in this structure, I will highlight this bond. See, this one bond and these two bond. So this is my Diene system. And to this Diene system, if you see this, the bond which is present in this system, second ring is in conjugation to this. Conjugation means which is separated through this only single bond, right? So there is a Diene and plus one extended. So I have here, I have able to find one extended. So that's why I can write 30 nanometer. There is only one extended conjugation. Okay, so 30 nanometer is there. Next fourth thing is I have to find the exocyclic bond. Similarly, I can find this. What I will do, I will label this system ring X and this system as an Y. Now what I will do for find, I will go for X. I will go a anti-clockwise from this carbon. I will rotate. I will go from like this. Here there is a no any double bond from outside. Here there is no any double bond from outside. Again there is no double bond, no double bond. Here also no double bond. Here also no double bond. So for X ring there is a zero exocyclic double bond, right? Now for wiring, now I will go for wiring. I will start from this and I will again go anti-clockwise. Okay, so for this there is no any double bond which is exocyclic to this wiring. If I go further, here I can see a double bond which is attached to this ring from outside through single carbon. So this is a one exocyclic. There is no exocyclic at this position. Next is there is no. Last is also having no. So how many bonds, exocyclic bonds are there? Only single exocyclic bond. So I have to add 5 nanometer again. Okay, and for substituent what I have to do, I have choose this ring system. So I will go for this carbon first. There is one substituent present here. There is no substituent here, also no substituent, no substituent here. On this carbon again there is one substituent. Even though this is present on this first carbon, this can be counted as an 2. Second time this is also substituent and last is this substituent. So total there are 3 substituent. That means I have to add 15 nanometers. Okay, so total 3 substituents I have to add 15 nanometers. Now there will be doubt in your mind that these two bonds represent the Diene system and this is an extended. So whether you have to find the substituent present on this extended system or not. The answer is yes. You have to find the for this substituent for this extended bond also. Why? Because this is in conjugation with this. As I have chose this Diene system, I have a option. I can choose this system also as an Diene system, right? Two double bonds, and this is an conjugation. Okay, so this is the case. Now the next example, similar type of example is there. Only one substituent is there. Okay, see, this is a Diene system. So I have added 215 homoannular. I have added 13. One double bond is there, 30, and exocyclic. Now for exocyclic, this ring is not having any substituent or any exocyclic bond, but this ring is having this double bond as an exocyclic. So I have added 5. Now I have to find the number of substituent. For that purpose, I will see these bonds. See, starting from this, there is 1. I will go further. There is nothing. Here there is 1, 2. As I go here, now there is one methyl group. So it will be 3rd and this is 4th. So total I have to add 20 nanometer for this particular structure. Okay, as an 4th substituent. So I will add 20 nanometer. Okay, now the next structure. This is a very simple structure. You can tell me how to find the lambda max. 215 is as it is. Homoannular, if there is any homoannular systems, yes. On this bond, see here in this ring there are 2 double bonds which are present in one single ring. So that's why this will be a homoannular. Okay, here there will be no any. See, this double bond you can count for this ring or this ring. Okay, as this is from you have written or I have like drawn it from this side, so that was it is counted for this ring. If it is there, if it is here in this ring, then we can count it as an homoannular. But at the time there is only, you have to consider it in only one bond or only one ring. So that's why 39 nanometer is there. Now see, for extended conjugation, this is our Diene system, double bond, single bond, double bond. It is again conjugated with this double bond, which is further conjugated with one more double bond. So there are total 2 extended conjugation. For now, for instead of 30, I have to add 30 into 2, that is 60 nanometer. For exocyclic bond, for finding exocyclic, again I will go for this ring. See, I have to start it from the this carbon. I have to go to the anti-clockwise. There is no double bond. See, at this position there is this double bond which is from outside, as well as this is through one single carbon. That's why this is an exocyclic. So one exocyclic for this, and for this ring system there is a no any double bond which are present from outside through single carbon. That's why there is no any exocyclic to this. So only I have to add 5 now. Now to find the substituent, what I have to do, I have to again go for this carbon. See, one substituent is there, there is no substituent, here is no substituent. This carbon is having this substituent here, right? 1 2, this is first, this is second, this is having a third on this side. Then there is nothing here, there is nothing here, there is again 1. So total 1 2 3 and 4. No need to go here, there will be 2 hydrogens only. So this will double bond is having this. So total 4. That means I have to add a 20 nanometers to this. 20 nanometers. Okay, so this is the example. Now I will again, I'll save it, I'll close it, and I'll open the few next example. Now for making the complications, or for making a to find out, to find everything given in this structure, we have to, what we have to do, we have to go for finding a little bit complicated structures. Okay, so the complicated structures means, complicated means it's not that much complicated, but only the what we call it as a, we are going to find each and everything. Means there should be a extended conjugation, there should be a homoannular system, and there should be exocyclic bond. There are so many substituent. Then we called it as an complicated system. Okay, so we have such examples now. See here. Here base value will be the same, homoannular. There is one homoannular system, extended conjugation, extended. I think we have seen this example. This is the fourth number file. I think we just now we have finished this. Okay. There is a, let me see. Yeah. Third and fourth, I think. Yeah. So this is the next example. See, it showed some complicated structures. Complicated means more than 2 rings. See now this ring system. Again, no, it is not in front of you or on the screen, but still you have to write like this. See, here for this base value will be 215. There is no any homoannular, because 2 double bonds are not present in ring, 0. But in extended conjugation, this is a Diene system which is attached to the one further extended conjugation, right? So this is a 30 nanometer. For finding exocyclic bond, we will go for this ring. See, as you are moving, there will be no any exocyclic bond. For B ring, for this ring, there will be 1, and again there is a no. For C, there is 1. So total 2. 2 means you have to add 10 nanometers for this finding the lambda max. See, and substituent, for substituent there will be 1, there will be the second, there will be third, and there will be fourth. So total 20 nanometers you have to add. Now see, this is an little bit extra conjugation type of system. We will do what we'll do. We'll take this bottom ring, and this we can say this is an our Diene system. Okay, so 215 plus we have to find the homoannular. See, this ring is having 2 double bond, this ring is having only 1, and this is having 2. So 2 homoannulars means you have to add 78. Okay. Then next is extended conjugation. This is Diene. So 1, then 2 and 3. So 3 means you have to add 30 into 3, 90 nanometers to this. This double bond is isolated. It is not conjugated with our Diene system. Hence, we have to neglect it. Okay. So 90 nanometers for extended conjugation. Next thing is for finding the exocyclic. See, for this ring, this bond is exocyclic. For this ring, this bond is exocyclic. And for this particular ring, this bond is exocyclic. Right? So this double bond is exocyclic to both the rings. So 2 plus this is 1, 3. So total 3 exocyclic bonds. That means you have to add 15 nanometers. Now the most interesting is find the substituent for this type of ring system. See, you start with this. There is 1, nothing. Here is also nothing, nothing. Again here, second 2, then 3, then 4, 0, 0, and 5. So total 5. So 5 into 5 total 25 nanometers you have to add for such a system. Okay, and few more examples are there. So we'll go for this example now. Same 32 15 nanometers base value. No homoannular system present because two double bonds are not present in one system anywhere. Right? Next, extended conjugation. This is our Diene system. This is having 1, 2, and 3. So that means total 90 nanometers you have to add. 30 into 3, that is 90 nanometers. Then we have to find, or we have to go for the exocyclic double bond. For this ring system, this is exocyclic. For this system, this is exocyclic, as well as this is exocyclic. So total 3, and for this ring system there is 1. So total 4 exocyclic double bond. You can find out this as this double bond is exocyclic to 2 rings. This bond is exocyclic to 2. Total 4. That means 4 into 5, that is 20 nanometers you have to add. Next is about substituent. So substituent 1, 2, 3, 4, 5, 6, and 7. So 7 5s are 35. You have to add 35 nanometers for substituent, and you have to make it sum, and you have to again write lambda max is equal to like a 327 nanometers. This is the case. So such a type of examples will be there. I'll share this all 4-5 files on the group, and I'll also add it on the this Microsoft team. You can download it, you can find your own, and you have to share it on the WhatsApp group. Okay, there are so many examples. You can take a screenshot, but no need to take a screenshot. I'll share this all this file with you. There's one more file, but during saving I think I have saved some thing. Yeah, see the timing difference is there. It's okay. We will do that later on. Okay, so there are 5 systems are there, and I'll share all this with you. You have to take a you have to find the lambda max for each and every structure. Okay, you have to match it with the given lambda max. And as I have told you, in the TYBSC Pune universities or any other universities book, there are so many number of questions, number of problems are might be given to you. Okay, so just go and find more and more, yeah, more and more examples that will do. Okay, just I'll do, so just go there and find more and more problems, and make a assignment of it. That will be assignment number 1 on UV visible spectroscopy, and you have to write down these rules. First question will be for write down all the rules for the finding lambda max for Diene system, and second question examples. At least you have to write 10 example. That will be your assignment number 1 for Diene system. Okay, so till now, if you have any doubt, any question, ask me. I'll explain that to you. Do you have any question?
No, sir.
This is very simple. I think this is a repetition of your third year BSc. So I don't find any difficulty in that.